Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Moore's Algebra class. Today we are going to continue with functions. We already have learned what a relation and a function are. A function is any relation where there is only one y value for any given x value. Okay, there can only be one output for any given input. We already know we learned how to yesterday write functions. We learned about function notation, and we learned how to evaluate functions. Today we're going to graph functions. And one way to understand functions is to graph them. In order to graph any function, though, just like always, guys, there's procedures. You must first solve for y. You want to get y all alone. And you're going to choose x values. Why can you choose x values? Because the x values are independent. So that means they can be whatever. You can choose to buy 7 tickets at the movies, or you can choose to buy 0. That's independent. So once you choose the x values, then you evaluate the function for each x value in order to solve for the y value. And remember that the y value is dependent. Remember that evaluate just simply means to plug in. So you're going to choose x values, you're going to plug it into the function, and you're going to find the y values. Now, sometimes you will be given the domain values to use. If they tell you evaluate the following function for domain values 5, 6, 7, 8, 9. Cool. You use the x values 5, 6, 7, 8, 9. You plug those into the function, and you find the y value. Great. But if not, sometimes, usually, they don't give you the domain. So in those situations, I recommend using what I call the moral 5. The moral 5 are very easy numbers. They're -1, -2, 0, 1, and 2. Why do I use the moral 5? Because you have the negative side here, you have the center 0, and you got the positive side 1 and 2. So always use the moral 5 unless the coefficient of x is a fraction. In that case, choose x values that are multiples of the denominator. Now, what I mean by that, if I have y equals, for example, 2/3 x plus 5, if I use my moral 5 here, I'm going to get fractions. And it's impossible to, not impossible, but it's extremely difficult and time-consuming to graph fractions. So whenever you have a coefficient, that's the number that is being multiplied to a variable, okay, to the x in this case. When you have a fraction being multiplied to the x, choose 0 and multiples of the denominator. Okay? So, let's see how this works. Number 1, graph this function. Well, I've got -x plus 2y equals 6. My first step is I got to solve for y. So how do I do that? How do I do that, guys? This is solving literal equations. We've done this already. We already had a test on this. Okay, someone said divide 2, but that's wrong. That is not going with the proper steps. Okay, how do we solve for y here, gentlemen? How do we solve for y, gentlemen? Thank you. This is a 2-step equation, so you're going to undo addition subtraction first. Don't I want to get the y alone, guys? Isn't the y being multiplied by 2, and aren't they adding a -x to the y as well? Haven't we already done equations and inequalities? You undo addition subtraction first. So you're going to add x to both sides. My friends, this is why we learned literal equations. That's why we learned this. Everything in math builds on itself. So if you don't know how to solve for a variable, I suggest you look up the video on literal equations. Now, how do we solve for y? Divide by 2. Very good. Now remember, this 2, you have to distribute it. You divide it to the 6 and you divide it to the x. So y is going to equal x over 2 plus 3. Now I've solved for y. Awesome. Great. Now let's make a table. They gave us the domain values that they want us to use. So we don't have to choose them. They've given them to us. So -4, -2, 0, and 2. Okay, my friends, all we're going to do is plug in. So what is y going to equal when x is -4? Well, what's -4 divided by 2? No, it's -2. What's -2 plus 3? 1. Good job. When x is -2, what's -2 divided by 2? -1 plus 3 is 2. When x is 0, 0 over 2 is plus 3. Y is 3. And last but not least, when x is 2, what's 2 divided by 2? 1 plus 3 is 4. And now I have made my table of values, and now I graph. -4, 1, -2, 2, 0, 3, and 2, 4. Connect the dots. You have just graphed a function. Does that make sense, gentlemen? So you're just simply going to plug in values for x. I always use the moral 5, -2, -1, 0, 1, or 2, unless they give you the domain to use, or unless there's a fraction being multiplied to the x. In that case, I use multiples of the denominator. May I continue? Thank you. Okay, graph the function. Okay, do they give us a domain to use here, guys? No, they don't give us a domain. So we're just going to use the moral 5. Why the moral 5? Do I have any fractions in front of the x? No. So I'm going to use the moral 5. So it's -2, -1, 0, 1, and 2. Okay, what is f of x? And actually, I shouldn't call that y, because they have it as f of x. Remember, f of x and y are the same thing. It's a fancy way of saying it. So f of x is going to equal the absolute value of -2. What's the absolute value of -2? 2, yeah. When x is -1, what's the absolute value of -1? Great. When x is 0, what's the absolute value of 0? Excellent. When f is 1, what's the absolute value of 1? When f is 2, what's the absolute value of 2? Excellent. Now, if you guys notice, this is an absolute value function. What do we know about absolute value? That it has two sides. Excellent. Let's see if you can recognize the two sides here. We got -2, 2, -1, 1, 0, 0, 1, 1, 2, 2. If you really investigate this and examine this, this is my positive side. And this is my negative side. And that's how a function of an absolute value will always look. Whenever you have an absolute value function, you're going to have a V-shaped graph. Sometimes it's pointing up, sometimes it's pointing down. I'm not going to get into why yet. There's a whole chapter on functions alone, which we'll get into it. But just so you know, an absolute value function is going to be a V shape. Always. Yes, sir. Oh. Does that make sense? Okay. Example 3. F of x equals x squared plus 2. They did not give us a domain to use, and I do not have fractions. So I'm going to use the moral 5. Absolutely right. -2, -1, 0, 1, and 2. Okay? So, f of -2. When x is -2, I got -2 squared plus 2, which equals 6. Very good. F of negative 1. I got negative 1 squared plus 2, which equals, excellent, 3. I got f of 0. 0 squared plus 2 will equal 2. Thank you. Great. F of 1. 1 squared plus 2 will equal 3. F of 2. 2 squared plus 2 will equal 6. Excellent. Excellent. Now notice the x is squared. When the x is squared, it renders a graph called a parabola. Whenever you have x squared, it's going to be a U-shaped graph. Whenever you have a parabola, it's going to be a U-shaped graph, either positive or pointing down if it's negative. Again, we'll have a whole chapter on that. But I just want to give you a heads up, a little preliminary info. So let's graph this sucker. I got negative 2, 6. So 1, 2, 3, 4, 5. Okay. And then I got negative 1, 3. I got 0, 2. I got 1, 3. And I got 2, 6. When you connect the dots, it's a U-shaped graph. Does that make sense so far, my friends? Promise? Okay. May I continue? Yeah? All right. Now, sorry. Okay, I want you to graph this function. I'm going to take this over here for a second. In fact, I don't even want to look at this for a second. Let me just block this off. Because I don't even want to pay attention to that right now. We'll talk about that in a second. Okay? Okay, my friends, I want to graph the function. Did they tell you what domain to use? Can I use the moral 5? You can, but do you want to? Nah, because you got a coefficient here that's a fraction, my brothers. So I'm going to use multiples of the denominator, and of course I always use 0, right? So I'm going to use 0, and I'm going to use negative 3. Negative 6, I got to have my negative side, and then I'm going to use 3 and 6, my positive side. You guys with me? Okay. Let's see how this works. Bless you. What's 1/3 times 0? Let me do it the right way. Sorry. F of 0. When x is 0, what's 1/3 times 0 plus 2? Great, 2. When x is negative 3, what's 1/3 times negative 3 plus 2? Well, 1/3 times negative 3 is negative 1. What's negative 1 plus 2? 1. F of negative 6. What's 1/3 times negative 6? What's negative 2 plus 2? Excellent. F of 3. What's 1/3 times 3? Plus 2? Excellent. And f of 6, when x is 6. 1/3 times 6 is 2. 2 plus 2 is 4. Excellent. So I have 0, 2, negative 3, 1, negative 6, 0, 3, 3, and 6, 4. And there you go. Does that make sense? Okay. You promise. Now, who can answer this? Find the value of x when f of x equals 3. 3. Thank you. Guys, isn't f of x the same thing as saying the y values? When y is 3, how did I get that? What's my x value? 3 in this case. Does that make sense? So when y is 3, that means x equals 3 in this particular function. What's the x value when f of x equals 4? 6. When f of x is 4, what's the x attached to that? 6. Does that make sense, guys? Awesome. Okay, last but not least. The function y equals 2.5x describes how many millimeters sea level y rises in x years. Graph the function. Use the graph to estimate how many millimeters sea level will rise in 3.5 years. Okay? Well, very simple. First of all, I hope you realize I don't have to estimate. I could go 3.5 times 2.5 and get the exact value, right? Right. But they want us to estimate, so let me show you the skills here that you need to succeed at this. Let's go ahead and go, let's go 1, 2, 3, 4, 5. Why am I not using 0? Because you can't have 0 years. Why am I not using my moral 5? Because you can't have negative years. So, when x is 1, y is, yeah, just plug it in, guys. 2.5 times 1 is 2.5. When x is 2, y is, when x is 3, y is, when x is 4, y is 10. And when x is 5, y is 12.5. Very good. Now, we're going to have to do some estimating here. We're going to do this to the best of our ability. When x is 1, 2.5 is about here, in between 2 and 3. When x is 2, y is 5. 1, 2, 3, 4, 5. When x is 3, it's 7.5. So 5, 6, 7, between 7 and 8. When x is 4, y is 10. And when x is 5, let's say this was 11. Let's say that's 12 and that's 13. So when x 1, 2, 3, 4, 5, we got 10, 11, 12. It's about there, 12.5. So we got that right there. Okay, you guys with me here? And if it was 0, yeah, it'd be 0. Now, they want to know, estimate the sea level, okay, in 3.5 years. Well, you got 1, 2, 3, 4. 3.5 is roughly here, right? So just follow it up. And what is it roughly? I would accept anywhere from 8 to 8.5 because we have an estimate. Now, yes, exact value, you plug it in, you're going to get 8.25. But by the graph, you estimated that it's between 8 and 8.5. Does that make sense, my friends? Talk to me, brother. Okay? No worries. We're golden? Awesome. Thank you very much. Hope you learned a lot. Have a great day.